Hello everyone, welcome to a video tutorial learning about solutions to linear inequalities. In this particular video, we're going to be given a graph. We have a graph here and an inequality. And we're going to talk about how to identify solutions, non-solutions, and how to test these solutions given a graph. Okay, so I've got 5x plus 2y is less than or equal to 18. And there's the graph of my inequality down below. And again, the graph shows all the possible solutions, ordered pairs x, y, that make this inequality true. So let's just pick a point right here in the shaded area. The coordinates of that point are going to be negative 10, it's my x value, and 5 for my y value. That's going to be a solution. It's in the solution set. So I'm going to go ahead and label that as a solution. If I put that x value in and that y value in, for x and y is going to be a true statement. We'll find a few other points, then we'll test out here. This point down here, there's an x value of negative 1 and a y value of negative 6. That's also in the shaded area, so it's also a solution. A different set of x and y values, if I put those in for x and y, it's going to make a true inequality. And lastly, on this one, it's less than or equal to, so anything on this line, since it's a solid straight line, is also going to be a solution. So I'm going to pick this point right here. That point has an x value of 0 and a y value of 9. That's also going to be a solution. It's right on the line. All right, let's test one of these out. So I'm going to pick this one on the line here, this point 0, 9. There's an x and a y value. X is 0, y is 9. And we're going to put that into my inequality. So we're going to do a testing over here. And just to verify that, yes, that is a solution. So we've got 5 times our x value, and our x value is 0. So 5 times 0 plus 2 times y. My y value is 9. And we want to check and see, is that less than or equal to 18? Well, 5 times 0 is 0. 2 times 9 is 18, so 0 plus 18 is 18. And is 18 less than or equal to 18? Yes, that's a true statement. So we just verified that that point is a solution. And I could do that for all three of these. Again, reading the graph represents all the possible points. There's so many of points, an infinite number that are solutions, that it's easier just to graph the boundary line and then shade the area where all the solutions lie. All right, now let's look at a couple non-solutions. All right, one non-solution is right here, the x-intercept. So this point when x is 10, y is 0. It's a non-solution. In other words, if I put 10 in for x and 0 in for y, that inequality will not be true. This point right here is not in the boundary region. So that's a x value of 7 and a y value of negative 9. So those two input and output values, that's not a solution either. So non-solution. Sorry for my sloppy writing there. And one other point, even though it's super close, this one right here, when x is 3, y is 2, that's not a solution as well. It's not in the solution region. So let's go ahead and test that point 3 too. It's super close, it's almost in there. So we're going to test out and show that it's not a solution. All right, so if x is 3, let's go ahead and put it in. 5 times 3, putting that in for the x value, plus 2 times y, so plus 2 times, well, when x is 3, y is 2, that's the value we picked, so let's put 2 in for y. Is that less than or equal to 18? All right, 5 times 3 is 15. 2 times 2 is 4. 15 plus 4 is 19. And there we just verified that 19 is not less than or equal to 18. So that's a false statement. And we just verified that it's not a solution. So there you go. Hopefully this really hammers in the point about when we're graphing linear inequalities and we're shading this area, what does this shaded area actually mean? We're showing this region of all the possible solutions, and we're showing what is not a solution by not being in the linear equality. And again, we can test these solutions with any ordered pair, with any x and y value or point from the graph, we can put them in to our inequality and just test to see is the point a solution or not. There's an example of a point that is a solution with a true statement and a point that is not a solution.